She does.
And then you have the nerve to be like, ah.
All right, so what we're going to do for example number 3, this is more practice in making things look the way we want them to. If you guys were to guess, what do you think we should do here?
I think you should, which one was it?
Oh,
We should make
screen so you guys can see it. All right, so what we could do here, there's lots of things we could do. If I let x go on the bottom, I mean, I already know what the limit is, but if I let x go on, if I let that blow up to infinity on the bottom, and I let it blow up on infinity to the top, in other words, let's just picture putting some numbers in there. Sine goes from, the range for sine is 1 to positive 1, positive 1 to negative 1, right? So essentially, whatever number we plug in here, we're either going to add or subtract 1. So if I let x equal 1,000, I'm basically going to have 5,000 over 1,000. If I let x equal 10,000, I'm basically going to have 50,000 over 10,000, which reduces down to 5, right? If I put 100,000 in, I'm going to have 500,000 divided by 100,000.
Why do we know the sine of x?
Well, because it'd be like 500,000 minus 1, or 500,000 plus 1, so we'll just kind of ignore that. So the point that I'm trying to make is that this is actually a first degree polynomial, if we kind of ignore sine, and that the bottom is also a first degree polynomial. And I don't know if you guys remember this, I taught it to you last year. When we look at end behaviors of rational functions, if they're the same degree polynomial, then you look at the leading coefficients, and whatever ratio for the leading coefficients are, that's going to be your limit. So our limit should be 5, but now we want to prove it algebraically, okay? So to prove it algebraically, I suppose we could do it like this. All right, that's the same thing, isn't it? Well, over here, this reduces to 5, so I've got the limit of 5 as x approaches infinity, plus the limit of sine of x over x as x approaches infinity. And this one I think we did yesterday. What's the limit of this as it approaches infinity? 0, right? Because this is just going to be 1 and negative 1 over infinity, which is 0. And then what's the limit of this as x approaches infinity? Well, there isn't an x at all. So I can't plug anything in, so it's just 5. So we have 5 plus 0 equals 5.
That was easy.